Liquid mixtures. A lab contains solutions of strength 15% and 50%. How much of each would you mix to get 28 ounces of an iodine solution of strength 25%? So just like in the previous mixture problem, I'm going to put the components of the mixture first and the mixture at the bottom. My mixture is of strength 25%, and my two components are the 15% solution and the 50% solution. Now for my column labels, just like with the dry mixture, I do start with amount, but this time it's specifically amount of solution. So I'm going to abbreviate here. In my middle column, I have strength as a percent. And in my far right column, I have the amount of pure iodine. So it's another amount, but it's the amount of pure instead of the amount of solution. So it still makes sense that if I multiply the amount of solution by the strength of the solution, I do get the amount of pure, in this case iodine, that is in that solution. So now I'm ready to start filling in the values I know exactly. I know the strength of everything. My 15% solution, I'm going to convert that percent to a decimal, 0.15. My 50% is going to be 0.50. My 25% is going to be 0.25. I also know that we want 28 ounces of solution of strength 25%, which is my mixture. So that's the amount of solution, 28. And I'm asked how much of each would you mix, and therefore again I want my variables x and y to be the amount of each of the components. I still multiply across to fill in that remaining column. So x times 0.15 gives me 0.15x. Y times 0.50 gives me 0.50y. And 28 times 0.25 gives me 7. So I make my two equations, again using the first column and the last column. And I never make an equation out of the middle column. So that my two equations are x plus y equals 28. Adding the amounts of solution, we should get the amount of the mixture solution. And 0.15x plus 0.50y equals 7. If I add up the amount of pure iodine I got from the first solution to the amount of pure iodine I get from the second solution, it makes sense that I get the amount of pure iodine in my mixture. So I'm now going to solve this by elimination, and I'm going to choose to target the x variable. And I'm choosing x just because it has a smaller coefficient in the second equation, so everything's going to stay positive if I choose to target x instead of y. But either way it works. So I'm going to multiply the top equation by negative 0.15, and I'm going to leave the bottom equation alone. That gives me negative 0.15x minus 0.15y equals 0.15 times 28 gives me 4.2, so this is going to be a negative 4.2. Leaving the bottom equation exactly as it is, 0.15x plus 0.50y equals 7. When I add these together, the x's drop out as desired. I get 0.35y equals 2.8. And as I divide both sides by 0.35, this would be another good time to bring in that calculator. I get 2 2.8 divided by 3.5 is 0.8. So y is equal to 0.8. Now remember, I do need a value for x and for y, and I need to express my final solution with labels and units. So I'm going to use 0.8 ounces of this 50% solution, and if I subtract 28 minus 0.8, sorry, I think I made a mistake there. That should have come out to be 8, I believe. 2.8 divided by 0.35, I must have written 3.5, is 8. So let's come over here and change that y to an 8, and change that y also to an 8. Now 28 minus 8 is going to give me 20 for my x variable, so I can now express my solution as 20 ounces of 15% solution and 8 ounces of 50% solution. And this would be my final answer. Again, make sure that your final answer has units. In this case, the units are ounces, and labels. In this case, the labels are the 15% and the 50% solution. It's important to make sure that the numbers go with the right labels.